Okay, so again, I'm going to repeat what I said, that I want you all to be ambitious and have a goal in life. And that is what will further you in your career. Okay, so like I said, when back in those days when I was a little girl, I knew I wanted to be a scientist, but I did not know how I would get there. But I was ambitious. I was always ambitious. And I have to say that, like, when, I did my, I went to Arya Center School. I graduated from there, and then I went to a college. I went to Marivanis College. I did my pre-degree there, and then I got into BSc Physics because I wanted to do physics. So I got into the physics program, and just like you all, I was just studying my physics, but I knew there was something in astronomy that I would like to do. Then I decided to go for my master's degree, and I ended up in Kottayam to do my master's. And they had a specialization in astrophysics, and that's where I started finding my passion in astrophysics. So being ambitious, back to my point of being ambitious, because you are ambitious and you wanted to get there, like I followed that. And that's why that opportunity opened up for me to do astrophysics. Okay, so I went there. Then when I was doing my master's, I got the opportunity to go to ISRO. That's where I did my project. And then I met a lot of scientists over there. I got like so empowered, so inspired. And then I decided that, okay, I wanted to go further in my career and want to be an astrophysicist. So my second advice to you is, like, you need to recognize opportunities, because opportunities don't always knock on your door. But when it comes to you, you need to realize that and grab it. So when I was in ISRO in Bangalore, my supervisor told me that, like, oh, there is a new program. It's a United Nations program, but it's an MTech course that is on space and atmospheric sciences. Why don't you just go and do it? And then I decided that was a great opportunity for me. So I grabbed it. So I went and did my MTech. I went to Gujarat. That's where I did my MTech. And again, I got to meet a lot of scientists. I traveled a lot of places. And again, from there, I decided, okay, I wanted to go and do a PhD. But the other thing is also that, like, in every career journey you take, life is not always smooth. Every time, things don't open up right away. Okay, there will always be failure. So when I finished my master's, MTech, I was waiting. I wanted to apply for a PhD, and I applied to lots and lots of universities here in US and Canada. And I got lots and lots of rejections. Can you imagine? I got lots and lots of rejections. And there were times I would just sit and cry. I would just think, like, why is that? Like, I'm not getting the opportunity, but every one of my other friends, they all went to become engineers and doctors and all that. But I have just wanted to be a scientist. But I did not give up. So I applied again and again. And then finally, I got the chance to do my PhD, and I came to Canada. So I did my PhD. I worked on something called supernova remnants. I'm sure, like, you all are budding astronomers, about it. Like, the death of a star is what you call as a supernova explosion. So I worked on supernova explosions. I studied, like, I was using telescopes to get my data, also satellites. And then once I finished my PhD, I decided that, okay, I wanted to go and advance my career. So I went to the States. I was working there as a postdoc, and then I became a research scientist. And now I go back and forth in the States and in Canada because my family is in Canada. So, and when I was in the States, I went to NASA. I was able to work with a lot of scientists over there. So the point is that, back to where I started by saying that you should be ambitious. This is where leads you to where you want to be. Okay. So that leads to my final point is that, like, you have to be very persistent. There will always be failure in life, but that's okay. You can cry if you feel sad, cry. 1 day, 2 days, 3 days, cried, but then get up and work for it again. You have to rise like a phoenix, never give up. So that's how I ended up where I am today. And, in the States, I run a program for the students, like lots of students like you. We work with a lot of high school students. We give them research opportunities. We give them data to work on, and it's fantastic to see all these young minds coming and doing all this research with us. Like they get wonderful opportunities now. So right now, where you are, like you get this 3-day experience, right? That I want you to take full advantage of it. So ask questions when you go and meet, the scientist at ISRO, or like you go to planetarium or somewhere. Always don't hesitate. Ask questions. No question is silly. No question is small or big. Always ask. Okay. The other thing I also want you to also realize is confidence. Be confident in yourself. Always, if you're confident in yourself, everybody else will believe in you, because you need to first believe in yourself. So these are some of my life advices for you. And now I will, if you have any questions for me, please ask me, because I want it to be more interactive.
Who has a question for Harsha? Some of you
come on, ask me something.
One second. Both. You need to speak to both.
Ma'am, I'm Anigit Bridge from Vadagara Amrita Vidyalayam. I have a question, like, what are you exactly doing in astrophysics?
Awesome. That's a great question. So what I do is I research on a star called magnetar. So basically, they are dead stars of a supernova explosion. And they have very high magnetic fields, like the highest magnetic field a source can have. So they are called magnetars. So I work particularly on magnetars because they're very exotic objects. They're like a neutron star. So when the stars die, they die in an explosion, but the core end up as a neutron star. And if this neutron star is rotating so fast, it becomes a pulsar. And magnetar is one type of a neutron star. So that's what I research. And so I get all my data from satellites by NASA. But I also specifically look into a high energy astrophysics, which means, the wavelength, right? Like there is optical, there's infrared, there is radio, there's X-rays and gamma rays. But X-rays and gamma rays are what we call as the high energy. They cannot penetrate inside the atmosphere. So if you wanted to study a source in high energy, you have to send satellites up there. So my research is basically studying the magnetars in high energy wavelengths.
So, do you get to have you ever found one yourself, discover a new magnet star?
Yes, I did. Yes. It was a couple of years ago. So magnetars, how we discover is they are very, very far away from us, and they are not seen with the optical telescope. They can be seen only in a high energy, like an X-ray or gamma ray telescope. So the one peculiar thing about the magnetar is that they show when they are active, they show huge bursts of energy. And sometimes the satellites detect that energy. So that's how we know it. So normally, when you ask about, do you discover it? It's not if we are constantly looking through a telescope, yes, we could probably differentiate that, you might discover. But this kind of discovery, especially in magnetar, is some satellite which is looking at it actually catches that burst, and then we study the source, and then we find out that, oh, that was actually a magnetar. So in that terms, yes, I have worked with magnetar. That was a new discovery, which was a couple of years ago.
So, ma'am, I have one question about this magnet star,
Magnetar.
magnetar. Basically, like, is it like a very hot type star, like a neutron star? You know, does it give up heat and light?
Yes, yes. That's how we see it. Yeah, but it's only in X-rays and gamma rays.
So, can like planets still revolve around this star? Like,
No, we don't have any planets revolving around this. These are like, it's like a neutron star. There are sometimes planets around neutron star, but a magnetar has a huge magnetic field. So there is no planet around the magnetar yet. It's gonna
so,
suck it up.
so it basically, if anything like a comet, asteroid, something, space debris just goes near this magnetar, it will just basically gobble it up.
Of course, because it has a high magnetic field, right? Super high magnetic field. Yeah.
Like
But we don't have, sorry?
like a black hole.
It's not black hole. It's not like a black hole. Like black hole, I'm talking about the magnetic field. So what is a magnetic field? You know, you can simply think about like a little magnet. But imagine a magnet like us, like literally, like which can say like if you have a credit card in your pocket, and then if a magnetar is like at the same distance as our moon, the magnetic field is so intense that it can wipe off every data from your credit card. That's how intense the magnetic field is. So in terms of like black hole, it's different because in black hole, like you don't get the light out, right? Like black hole has a high gravitational field, but this is different. This is the magnetic field.
So does it like attract only metallic objects, or like organic matter can it attract?
It's an isolated neutron star. When I say isolated, it means like it's just standing by itself. Like it's not, you know, when you say like attract something, like for example, if it's a binary star, yes, it can accrete the matter, right? Like it just sucks up some of the matter from another star. But these magnetars are just isolated. So it's just by itself.
Okay, ma'am. Thank you.
You're welcome.
Good morning, ma'am. I'm Karthikeyan
Good
Shah
morning.
from Amrita Vidyalayam, Thiruvananthapuram.
Yeah, I want to see your face. Come on, come to the front.
Ma'am,
Okay, bend down a little bit. I can't see you. He is very tall. Look at you. Like, which grade are you?
I'm in 9th.
9th. Okay, okay.
So, ma'am, I just wanted to ask, what is a nebula? I don't know it.
Nebula is a gaseous cloud. It's just a mix of debris and clouds together. That's just what a nebula is. Simple.
Okay, thank you, ma'am.
Thank you.
So is this your first experience with astronomy, or have you ever had anybody like in the audience, like have you ever had any astronomy background or lessons before?
No, ma'am, first time.
First time. Okay, okay. Okay, that makes sense.
Thank you, ma'am.
Okay, okay. Not touching, not touching. Yeah. One second. Yeah, just little gap, like this. This much okay.
Hello, ma'am. I'm Yuval Krishna from Amrita Vidyalayam, Talisheri. I am Yuval Krishna from Amrita Vidyalayam, Talisheri, and I have a small question. It is that what are the chances that a star could turn into a supernova? I mean, it's like it would be a neutron star or maybe even a black hole. What are the chances that it would happen?
That's a good question. So, you know, the stars have masses, right? Like some stars are like much bigger than our sun. Some stars are like much smaller than our sun. So the stars which are like, say, 10 times or like 20 times massive, like larger than our sun, they undergo a supernova explosion, and only those stars will form a neutron star. But anything that the size of our sun, smaller,
they will not. They become a white dwarf.
Okay, ma'am. Thank you.
Clap, clap. You come to the front. And then no touching. Mics.
Harsha, ma'am.
Namah Shivaya.
So I have two questions. What is your opinion about first white hole, then two multiverse?
I really don't have any opinion about both because, I am someone, I'm an observational astrophysicist, which means like I tend to believe what I see. And white holes and multiverse, yes, these are all like the theoretical side of things. And if you personally ask me, I don't know. I mean, as theoreticians, they always come up with lots of, explanations, but do I believe in it? I don't know yet because there is no evidence for it.
Black hole can attract light. What does it mean that light cannot escape? We all, when I heard it, I just by hearted it. Okay, light cannot escape from black hole. What does it exactly mean?
Mm-hmm. So, every object gives out light, right? So, for example, say, you can see things because the object is emitting light, right? So what you see around, because, there is light reflected off, which is optical light. That's where you can see it. Sometimes there is infrared light. There are all different kinds of wavelength light, and they are all giving out that light. So you tend to see it. But now in the case of black hole has a huge gravitational field, right? So what happens when you have a gravity on Earth? Like everything is falling onto the Earth. It's not like flying around. So now in terms of black hole, the gravitational field is so huge that even the light that passes around it, right, it cannot escape out of it. And that's why we say that, like, it doesn't emit any light, because there is no escape. The gravitational field is so huge that I know this concept is really hard to understand, because we always think like, oh, how can light just not escape, right? But that's why we say that light cannot escape, only because of that huge gravitational field. It's a little bit more complex, but I just explain it in the terms that like maybe you would understand that, like, that's what we mean by saying there is no light coming.
Yes, ma'am. So we know that everything which has a beginning, it has an end. So we know that after supernova, a black hole, if it is a massive star, then a black hole will be formed.
Not the magnetar. Magnetar is
excuse me, ma'am.
Yes, go on.
Yes. We know that everything which has a beginning, it has an end, right? So we know that after a supernova, a black hole is formed if it is a massive star, right?
Mm-hmm.
So is there any end to black hole? Will its gravitational field become more less powerful?
It might say yes, yeah, like, but it will take billions and billions of years later. Like, maybe the black holes, they don't, there's not enough energy. Like everything kind of like, like dies off with time. But it may not have that much of a gravitational field anymore, and that's why like a lot of black holes are not even detected sometimes, because it doesn't have that much energy to give up. But I want to correct one thing you said earlier, that all the supernova remnants, some of them give rise to neutron stars, but only very extreme supernova remnants can create a black hole.
If a black hole attracts all the objects around it, will it become more powerful, or will it remain the same?
It will remain the same. It's not about the power. Is not because it's accumulating the nearby stars. It's from the central engine that is giving off the energy. It depends on how big and massive the black hole is that gives up. That makes it more powerful. So some black holes are like, in the black hole regime, like we have like, supermassive black holes, like much, smaller black holes, bigger black holes. There are different sizes of them. So that makes them more powerful.
Okay, ma'am. Thank you.
Yes, sir.
I has a question that black hole has a axial disk, and a star is coming closer to the black hole, and it splashed to the axial disk. So the black hole will attract the axial disk. Why don't it is take very time? The accretion
So repeat again. So there is this black hole and a nearby star, and it's accreting the material from the star, right? Yes. So so then what was your question again? Like the black hole is attracting that accretion disk because that forms the small disk around the black hole. Okay, so then what's the next part of the question?
the accretion disk will attract to the black hole.
Sometimes it, yes, okay. So sometimes, depending on how massive and big the star is, like, do you mean that, like, can this accretion disk be all sucked up into the black hole? Do you want to speak in Malayalam? Like, you can ask me in Malayalam. I understand Malayalam totally very fine. So you can talk to me in Malayalam.
accretion disk black hole like collapse ചെയ്യുമ്പോ ആ accretion diskനെ black hole തിരിച്ച് അതിന്റെ ഉള്ളിലേക്ക് വലിക്കൂലേ? ആ accretion diskൽ തന്നെ ഇരിക്കൂലേ ലൈറ്റ്?
No, it takes years to happen, but accretion disk, when it, so are you trying to say that, yeah, light, that light doesn't, because the accretion disk has a, like, it gives off light, but once it gets into the black hole, probably, like, it doesn't come out anything. I know your question is, it's difficult for me to understand right now, and I'm not an expert in a black hole to also, like, explain more on what the physics there is.
Okay, ma'am. Thank you.
I know black hole is a very interesting subject for everybody. It's fascinating, but for some reason I haven't done more research on the black holes.
Okay, so the last question for today's session. Introduce yourself, please.
My name is Abhinav Shankar from Trishur Amrita Vidyalayam. My question is, if before supernova, with that star, there will be a planet. But after that supernova...
No. Before supernova, there is no planet. It's just a star, right? Yeah. What are planets? Planets are different.
That if there will be any companion partner planet will be there?
There is no planet. Planets are different, Monet, because, here, we are just talking about like a cloud of gas, right? So it's just a star. Before supernova, it will be a star.
My question is, അതിന്റെ കൂടെ സ്റ്റാർ ഉണ്ടെങ്കിൽ, ഒരു സ്റ്റാറിന്റെ കൂടെ ഒരു പ്ലാനറ്റ് ഉണ്ടെങ്കിൽ, അങ്ങനെ
സ്റ്റാറിന്റെ കൂട്ടത്തിൽ ഒരു പ്ലാനറ്റ് ഉണ്ടെങ്കിൽ okay.
After supernova, that planet will exist or it will destroy?
I would say, depending on how big of an explosion it is, right, and also the distance to where this planet is, നമ്മുടെ എന്താണ് ആ പ്ലാനറ്റിന്റെയും എന്താണ് ആ സ്റ്റാറിന്റെ ഡിസ്റ്റൻസ് അനുസരിച്ചിരിക്കും whether that planet will exist or not. If they're very close,
if it exists, that is light, it will rotate again, rotate.
Yes. Yeah.
Yes. That neutron star, around neutron star.
Around the neutron star, yes.
Okay, ma'am. Thank you, ma'am.
Hello, Harsha.
So nice. Teacher.
Who started the Astro Club? You know something, children? She only started helped me to start the Astro Club. And
No, it was all her. It was all teacher's idea.
still, I really owe you. Okay. Because I am following you. And according to your instructions, I am doing that. Okay. I know because the latest technology, I'm just behind, no?
That's why now you have Julius to write to help you.
Julius have come, so Julius has come, so no, it's easy for me now. Children, you must
Yes.
understand that she was like a student like you in my class. That's what I wanted to make highlight. Now just look at her, how she is, and yes. So I want everyone to become like this in their fields, because this is the best motivation which you can hear in your life. Okay, thank you. And yes. And one thing you must understand, that even though she is a high position, still she is down to earth, very obedient, a very loving girl. Yes, thank you, Harsha, so much.
Thank you, teacher. Thank you so much.
Actually, we are assembled at Amrita Vidyalayam. They are hosting the program. There are 80 students from various parts of Kerala. So this Amrita Vidyalayam Trivandrum is hosting this function program.
Okay.
3 days for program. So I
Okay.
really
Someday when I come to India, I promise that I will come and meet all the students.
definitely, yes. Oh, wow. Can you turn the camera? Now, our principal ma'am is there. We'll turn the camera.
Okay.
She's there. And on is ma'am. My favorite ma'am.
Namaste, ma'am.
Good morning, and thank you so much for sparing your valuable time and clearing the doubts of our children. Hope it would be a wonderful day ahead today for our kids to explore and to understand more about the space and all. Thank you, Harsha. Thank you so much. Namaskar.
Thank you so much. Thanks for having me today.
Thank you, ma'am. Thank you so much. Yes, anyway, we are going to conclude the session. So, Namashivaya, Om Amradeshwari Namaha, on behalf of Amrita Vidyalayam Trivandrum, and Julius also is here. So, on behalf
everybody,
of
bye and enjoy the day. Learn lots.
On behalf of Astro Club, Amrita Vidyalayam, we thank you from bottom of our heart for your spending. So, what's the time now there?
It's 10:45 p.m. Night time.
Oh my God. Okay. Thank you. Still, you were kind.
Yeah, my kids are sleeping. My family's all sleeping.
Thank you so much. Anyway, thank you. We'll meet again once again like this.
Yes. Okay.
And guide us.
Take care.
Thank you.
Bye.
Bye. Bye. Namashivaya.